mag-aral sa math, walang maiiwan. Math-sayang Math-aral tayo ng Math-tuto upang ika'y umasenso. Maging matyaga, maging matalino, halina Math-aral na tayo. Maging matyaga, maging matalino, halina Math-aral na tayo. Halina Math-aral na tayo. Halina Math-aral na tayo. Halina, 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 aral na tayo.
Math-sayang araw muli sa ating mga viewers. Ngayon naman ay pakikilala ko sa inyo ang ating lecturer para sa Grade 10, Project SOAR, Week 5. She is a Teacher 1 in City of Mandaluyong Science High School for 5 years. She is a graduate of Bachelor of Science in Electronics and Communication Engineering at Polytechnic University of the Philippines. She also earned 30 units for Teacher Certificate Program at University of Makati. She is also a CLAID Module writer and currently a Grade 10 Math teacher and advisor. Ang susunod na lecturer natin for today, Mrs. Aileen S. Anastasio.
Good day! Welcome once again, Grade 10 students, to our Project SOAR series of online academic review of mathematics for Grade 10. We are now on week 5 of the third quarter of this school year. And our topic for today is an enhancement of the lesson about solving problems involving permutations and combinations. And this is applied under the learning competency with the same learning objectives. Solve problems involving permutations and combination. Again, I am Teacher AILEEN Anastasio from CMSHS, your guiding teacher for today's lesson. Are you ready, students? To begin, let us recap the difference between permutation and combination. When you are counting the number of ways to choose and arrange a given number of objects from a set of objects in which order does matter, then it is a permutation. So it means to say here, in permutation, order is important when we are dealing problems that requires a specific arrangement of position. The common keywords usually found in a permutation problem are the words like arrangement, ordered, and in a row. And the common situation wherein permutation being applied is like in sequence of lock, passwords, and codes. Placement on the competition. Example, first place, second place, third place. Organizational position. Example, president, vice president, secretary, and so on. Bookshelves, letter arrangement, seating arrangements, or any situation occupying spaces with regards to the sequence of position. Now, what about the otherwise of permutation? When you are counting the number of ways to choose a certain number of objects from a set of objects in which order of the chosen objects does not matter, then it is a combination. Meaning to say, we are counting groups regardless of the order of the objects within the group. The usual keywords that can be found in combination is like the words selection, choose, pick, and combination. And the typical situation wherein combination being applied is like forming a committee, selection of things, forming geometrical figures by joining its points, or any situation forming a group. Permutation has two types: permutation with repetition and permutation without repetition. So when we say permutation with repetition, it means to say that the objects, the things, or the likes can have a chance or possibility to repeat in the number of choices. So sa madaling salita, kung nabigyan ka na ng pagkakataon sa una, sa pangalawa, at sa mga susunod pang pagkakataon, maaari ka pang umulit. So permutation with repetition happens when an object has n different types. We have n choices each time. So the formula for this is permutation of n objects raised to r as the number of times the number of choices repeats. Ano naman ang permutation without repetition? Permutation without repetition is a case wherein we must reduce the number of available choices each time. Sa madaling salita, kung nabigyan ka na ng pagkakataon sa unang posibilidad, hindi ka na maaaring umulit o mabigyan pa ng panibagong pagkakataon. Ang pagkakataon na yon ay ibibigay naman sa susunod. Kaya kung tapos ka na, tapos ka na. Wala nang second chance. Okay, meron ding dalawang case under permutation with repetition. The permutation of n objects taking all n at a time, and the permutation of n objects taking r at a time. In the permutation of n objects taking all n at a time, ibig sabihin nito, in a set of n objects, lahat ay magkakaroon ng pagkakataon na mapili hanggang makarating sa last option. Kung baga sa raffle, hindi ka man nanalo ng grand prize, at least may consolation prize pa rin. So the formula for this case is permutation of n objects taken n all at a time is equal to n factorial. And the permutation of n objects taking r at a time, the formula is n factorial divided by n minus r factorial. So, ginagamit ito kung fewer or iilan lang yung number of objects na sinelect mo at i-arrange mo out of the total number of objects. And that is represented by r. Again, n is the total number of objects to choose from. R is the number of objects chosen from n. And n minus r, that is the number of objects you did not choose or not selected. Example number 1. In a meeting, it is required to sit 5 men and 4 women in a row, so that the women will occupy the even places. So how many arrangements are possible? Solution to this, pwede natin itong simulan sa tanong na, does order matter? If order matters, ano ba ang keyword na nag-identify that the arrangement or order is important? The keyword is in a row. So this is a permutation. Ano naman ang condition na nire-require sa order ng arrangement? The condition is women should be placed on a specific position, and that is occupying even number places. So we can solve this by using both permutation formula and multiplication principle. So let me illustrate the arrangement using lines to represent the 5 men and 4 women positions. So unahin natin i-place yung may condition. The 4 women occupying even number places, 2, 4, 6, and 8. And on the remaining places, this will be occupied by the 5 men. Now, para mas maintindihan natin, palitan natin yung images ng letters that will represent men and women. For women, let me represent them with letter W. And letter M naman for the 5 men. And as you notice, the sequence of their position is in alternating order. Though, alternating sila, nakafix na si women sa even places. And these 4 women can be arranged in any order among themselves in 4 times 3 times 2 times 1 equals 4 factorial or 24 ways from the permutation of 4 women taken 4 at a time, while the 5 men can be arranged in any order among themselves occupying the remaining places in 5 times 4 times 3 times 2 times 1 equals 5 factorial or 120 ways from the permutation of 5 men taken 5 at a time. And then, let us combine them using multiplication principle. 24 times 120 is equal to 2,880 ways arrangement of 5 men and 4 women occupying even places. Now, let us try it by yourself. Let us check if you can answer the next permutation problem similar to this problem situation. In a computer room, 6 girls and 5 boys are randomly seated in a row of chairs. So how many seating arrangements are possible if the girls and boys must sit alternately? And these are the following choices. Is it A, 14,400 ways, B, 86,400 ways, C, 1,036,800 ways, or D, 1,814,400 ways? I'll give you a few seconds to solve for this problem. And the answer is letter B. There is 86,400 ways, and you are correct. In the problem, it is stated that the condition of the sequence of arrangement is in alternating order. To solve for this, unahin nating i-line up yung objects with a greater number, and that is the girls. Okay? So with vacant space in between, para ito sa boys dahil nga ang sequence ng seating arrangement nila is in alternate. And these girls can be arranged in any order among themselves in 6 factorial ways. Now, for the boys, ilagay natin sila sa vacant spaces. And these boys can be arranged in any order among themselves in 5 factorial ways. So, all in all, by multiplication principle, 6 factorial times 5 factorial is equal to 86,400 ways of seating arrangements if the boys and girls must sit alternately. Now, let us have example number 2. Example number 2. How many different possible permutations can be formed from the letters of the word circle, such that the vowels are never together? Keyword, the word permutation, because it is already stated in the problem. And this is a kind of distinguishable permutation. Recap ko lang ng konti the concept about distinguishable. Distinguishable permutation is a repetition of indistinguishable objects, or objects that are alike. Like in the word circle, it has two letters that occurs twice, or the same. So we cannot distinguish the two letters that are alike. Remember also na mas maliit yung nagiging total number of possibilities sa distinguishable, because the group of the same word na na-form is counted as one outcome na lang. So you can see that kapag nilatag mo lahat ng arrangement using listing method. Now, kung alam mo na yung concept behind this kind of permutation, pwede ka na gumamit ng formula to shorten the process. So the formula for distinguishable permutation is n factorial divided by r sub 1 factorial times r sub 2 factorial times r sub 3 factorial and so on. So this letter R are just notations for the things that are alike. So it can be denoted also as different letters. So going back to the problem, let us apply the formula. However, what is the condition being required? The condition is the vowels are never together. To solve for this problem having that condition, these are the following steps. Step 1. Find the number of possible permutations can be formed from the letters of the word circle without restrictions. So, ibig sabihin ng without restriction, walang condition na nire-require. Step 2. Find the number of possible permutations can be formed from the letters of the word circle, such that the vowels I and E always together. Step 3. Subtract the number of possibilities obtained from step 1 to the number of possibilities obtained from step 2 to find the different possible permutations from the letters of the word circle, such that the vowels are never together. Now, let us solve the permutation for step 1. Step 1. Solve the permutations without restriction of the word circle. The word circle contains 6 letters, and here are the following frequency of each letter. Letter C occurs twice, and the rest of the letters I, R, L, and E occurs once. Since letter C occurs twice, therefore, we'll apply the distinguishable formula. Thus, the permutation without restriction of the word circle is 360 ways. Now, for step 2, let us solve the number of permutations with vowels always together. Remind ko lang na even if the vowels group as one unit, the letter C still exists and occurs twice. And we'll apply again here the distinguishable formula. So we are going to find out what's on in the numerator and in the denominator. So let me illustrate first the arrangement of the word circle using lines. So interchange na natin yung position ni letter L kay letter I. We need to do this to group those vowels together and be counted as one unit. However, we can still arrange the two vowels within their unit as 2 factorial ways. Next, we'll consider permuting the other letters together the vowels we group as one unit. So we have 5 times 4 times 3 times 2 times 1 is equal to 5 factorial ways. Now, we have 5 factorial times 2 factorial in our numerator. What about in the denominator? Since letter C occurs twice, then we'll divide 5 factorial times 2 factorial by 2 factorial. And that will give us 120 ways. Now, let us subtract 360 ways to 120 ways. And so, we have 240 ways to arrange the letters of the word circle such that the vowels never together. Now, let us try it by yourself once again. Let's check if you can answer the next permutation problem similar to this problem situation. Which of the following factorials represent the different arrangements that can be formed from the letters of the word permutation, such that the consonants are never together? You can follow the equation below in solving for this type of problem. Permutations never together is equal to permutations without restrictions minus permutations always together. So these are the following choices. For letter A, 11 factorial divided by 2 factorial minus 6 factorial times 6 factorial divided by 2 factorial. Letter B, 11 factorial divided by 2 factorial minus 6 factorial times 2 factorial divided by 2 factorial. Letter C, 11 factorial divided by 2 factorial minus 6 factorial divided by 2 factorial. And for letter D, 11 factorial divided by 2 factorial minus 7 factorial times 5 factorial divided by 2 factorial. And I'll give you few seconds to apply and solve this problem. And the answer is letter A, and you are correct. This part of the permutation without restriction. The word permutation contains 11 letters of which 2 letters are alike, and that is why we divide it by 2 factorial. For the permutation always together, we have 6 factorial for the 5 vowels and 6 consonants that comes together. Then we multiplied it by 6 factorial divided by 2 factorial, the group consonants with 2 letters that are alike. Then, get the difference of these two arrangements. So we have 19,699,200 ways. Okay, I think you all understand how to solve this type of problem. So now, we can move on to the next example of solving problem. Example number 3. How many straight lines that can be formed by 8 points of which 3 are collinear? So this kind of problem, the situation is forming geometrical figures by joining the endpoints. The order of selection of points here does not matter, as long as it can form the required figure. So this is a combination. Condition: 3 of the points from 8 points are collinear or lie on the same line. Okay, recap ko lang ng konti si combination formula. The formula for combination is n choose r is equal to n factorial divided by n minus r factorial times r factorial. So, ibig sabihin ng formula na to, the number of possibilities of combination is equal to the number of ways to arrange all the objects divided by the product of the number of ways to arrange the objects that are not selected and the number of ways to arrange the objects that are selected. Let me remind you that there are generally fewer ways to select objects when order does not matter. Ibig sabihin nito, mas maliit yung expected outcome ng combination compare sa permutation. For example, the permutation of 3 letters ABC. So, in permutation, may 6 arrangement lang tayo dito. ABC, ACB, BAC, BCA, CAB, and CBA. Now, ang equivalent nito sa combination is one combination only. Why only one? Since di importante yung order of arrangement kay combination, ABC is the same as ACB and the likes. Kaya counted as one unit na lang siya because they have the same group of letters. Okay, let us go back to the problem. How are we going to apply here the concept of combination? Solution? Actually, we can use a formula here. And the formula in getting the number of straight lines that can be formed by joining the endpoints of which m points are collinear is n choose 2 minus quantity m choose 2 minus 1, where n is the total number of points and m is the number of collinear points. However, bago natin i-apply ito directly, we still need to know how the formula works in this problem. So these are the following steps that we can consider in solving for this kind of problem. First step, find the number of possible combination of straight lines that can be formed by joining all the given points and assuming that all are non-collinear points. Second step, find the number of possible combination of straight lines that can be formed by joining the points that are collinear. Third step, subtract the number of possibilities obtained from step 1 to the number of possibilities obtained from step 2 to find the number of straight lines that can be formed by joining the 8 points of which 3 are collinear. Okay, so let us begin solving for step 1. Now, let us do step 1. Find the number of possible combination of straight lines that can be formed, considering all the given points and assuming that all points are non-collinear. Solution to this, it is important to recall first the concept of how many points do you require to draw a straight line. Pauna ko lang ha, when we say straight line here, it pertains to a line segment, endpoint to endpoint. So there are 2 distinct points to determine or draw exactly one straight line. Now, how many ways can you select a group of 2 points from 8 non-collinear points? The answer here is 8 choose 2. And 8 choose 2 is equal to 8 factorial divided by n minus 2 factorial times 2 factorial equals 8 factorial divided by 6 factorial times 2 factorial. Performing this will give us 28 ways. So, validate natin yung 28 ways na to through illustration. Suppose, ito yung ating 8 non-collinear points. And we're going to name them as A, B, C, D, E, F, G, and H. Then, we'll connect the points to form a straight line and count natin kung ilan ang na-form regardless of the order. Okay, so let us start joining the points A and B. Then, A and C. Then, A and D. Then, A and E. Then, A and F. Then, A and G. Then, A and H. Next is joining the points starting from point B up to point H. Next is joining the points starting from point C up to point H. Then, joining the points starting from point D up to point H. Next is joining the points starting from point E up to point H. Next is joining the points starting from point F up to point H. Next is joining the points G and H. Okay, remind ko lang ha, in combination, AB and BA is considered as one straight line, and the other joining points na similar to this. Now, let us count the points that form a straight line. So we have 28 ways or combination of points to form a straight line from 8 non-collinear points. So we are not done yet. Proceed tayo kay step 2. Step 2. Find the number of possible combination of straight lines that can be formed of the points that are collinear. Solution to this, let us know how many ways can you select a group of 2 points from 3 collinear points. So let me illustrate the 3 collinear points. Suppose these are the 3 points, and I'm going to name this as points A, B, and C. Now let us join the points A and B, or B and A, B and C, or C and B, A and C, or C and A. Again, in combination, points AB and BA is equivalent to one straight line. And so as points BC and CB, points AC and CA. So the number of ways to choose 2 to form a straight line in these points is 3 choose 2 or 3 ways. However, the 3 points lie on the same line. Thus, 3 choose 2 must be subtracted by 1. So bakit tayo nag-subtract ng 1? Because we need to disregard yung combination of points na nag-form ng line overlapping AB and BC. And that is AC and CA. So we have 3 choose 2 minus 1 equals 2 ways. Okay. Now, proceed tayo sa last step. Combine na natin the possibilities obtained from step 1 and step 2 by getting their difference. Step 3. Subtract the number of possibilities obtained from step 1 to the number of possibilities obtained from step 2. A choose 2 minus quantity 3 choose 2 minus 1 equals 28 ways minus 2 ways. So, the number of straight lines formed by joining the 8 points, of which 3 are collinear, is 26 straight lines. Now, let us try it by yourself once again. Let us check if you can answer the next problem similar to this problem situation. Which of the following expressions represent the number of straight lines that can be drawn from 12 points on a plane, out of which 5 points are collinear? You don't need to literally draw or ilatag lahat ng possibilities. That is just to show you and make you understand how the formula works in this kind of problem. You can now use the formula in solving problem of this kind. And this is the formula. N choose 2 minus quantity M choose 2 minus 1. And these are the following choices. Letter A, 12 choose 2 minus 5 choose 2 minus 1. Letter B, 12 choose 2 minus quantity 5 choose 2 plus 1. Letter C, 12 choose 2 plus 5 choose 2 minus 1. Letter D, 12 choose 2 minus 5 choose 2 plus 1. I'll give you a few seconds to solve for this. And the answer is letter D, and you are correct. Bakit letter D? Because when you perform this expression, this will be the simplified answer. And this will give us 57 straight lines. Okay, as a key takeaway, if the problem calls to form a triangle joining the endpoints as vertices and out of which there are endpoints that are collinear, you can use this formula. N choose 3 minus M choose 3. Now, proceed na tayo in the next example problem. Example number 4. A committee of 5 persons is to be formed from 6 men and 4 women. In how many ways can this be done when at least 2 women are included? The situation here is forming a committee of 5 persons. So the order does not matter here. So it is a combination. What is the condition needed? The condition is at least 2 women should be included in the committee of 5 persons. Solution to this, our N here is a total of 10 persons. 6 choices for men, and 4 choices for women. And when we say at least 2 women included, it means to say more than 2 women should be included in forming a committee of 5 persons. So it is either 2 or 3 or 4 women. A minimum of 2 and a maximum of 4 women. Then kukuha tayo sa 6 men ng ilan nabubuo sa combination ng committee of 5 persons. Okay, let me present the solution using a table. In the first column, this is for the options or selection. In the second column, this is for the number of ways written in combination notation form. For the third column, this is for the equivalent numerical form of the number of ways. So let us start with the first column. We will form a 5 persons committee, either 2 or 3 or 4, women included per combination. But do not forget if we have a conjunction or, it means to say, to add all the options. So, for the first option, a 5 persons committee with 2 women included, we have a combination of 2 women and 3 men. But do not forget, if we have a conjunction and, it means to say, to multiply. Now, the number of ways selecting 2 women and 3 men in notation form is 4 choose 2 times 6 choose 3. And this is equivalent to 120 ways. For the second option, a 5 persons committee with 3 women included, we have a combination of 3 women and 2 men. And the number of ways it can be done is 4 choose 3 times 6 choose 2. And this is equivalent to 60 ways. For the third option, a 5 persons committee with 4 women included, we have a combination of 4 women and 1 man. And the number of ways it can be done is 4 choose 4 times 6 choose 1. And this is equivalent to 6 ways. Then, add all the possibilities of each option. 120 plus 60 plus 6. So we have 186 ways to select and form a committee of 5 persons with at least 2 women included. Now, let us try once again solving a problem similar to the problem situation we have here. A box contains 2 red balls, 3 yellow balls, and 4 blue balls. In how many ways can 3 balls be drawn from the box if at least 1 yellow ball is to be included in the draw? Our N here is a total of 9 objects. 2 for red balls, 3 for yellow balls, and 4 for blue balls. Then, per option or draw, we need 3 balls with at least 1 yellow ball. At least 1 yellow ball means, in the combination, our options should include either 1 ball, 2 balls, or 3 balls. And here are the following choices in combination notations form. Is it A, quantity 3 choose 1 times 6 choose 2, plus quantity 3 choose 2 times 6 choose 1, plus quantity 3 choose 3 times 6 choose 0 weights. Letter B, quantity 3 choose 1 plus 6 choose 2 times quantity 3 choose 2 plus 6 choose 1 times quantity 3 choose 3 plus 6 choose 0 ways. For letter C, quantity 4 choose 1 times 5 choose 2 plus quantity 3 choose 2 times 6 choose 1 plus quantity 2 choose 3 times 7 choose 0 ways. And for letter D, quantity 2 choose 1 times 7 choose 2 plus quantity 2 choose 2 times 7 choose 1 plus 9 choose 3 ways. I'll give you a few seconds to solve for this problem. And the answer is letter A. And you are correct. Quantity 3 choose 1 times 6 choose 2 plus quantity 3 choose 2 times 6 choose 1 plus quantity 3 choose 3 times 6 choose 0. And that is equivalent to 64 ways. Good job! As a key takeaway, if the condition needed in the problem as for an at most n objects included, let's say, for example, at most 3, it means to say in the combination, our options should include either a maximum of 3 balls, then 2 balls, or 1 ball, or nothing. So now, let us have the last example. Example number 5. If 3 mathematics books have been selected from 5 different mathematics books and 4 English books have been selected from 6 different English books, in how many ways can 7 books be arranged on a shelf if the 3 mathematics books remain together? In this kind of problem, we have 2 different situations. The first one is the selection of books, and in this case, the order does not matter. So, this is a combination. While on situation 2, after the selection of the books, it requires an arrangement of books on a shelf wherein the 3 mathematics books remain together. And with that, the order matters. And so, this is a permutation. Solution to this is to combine the number of ways or possibilities obtained from situation 1 and situation 2 using multiplication principle. So let us begin solving for situation 1. Situation 1. Let's do the selection of 7 books, mathematics and English out of each total number of books. Let us start with the mathematics books. The number of ways of selecting 3 math books from 5 different math books in notation form is 5 choose 3 ways. Now, for the English books, the number of ways of selecting 4 English books out of 6 different English books in notation form is 6 choose 4 ways. So the number of ways in selecting 3 math books and 4 English books out of their total number of books in notation form is 5 choose 3 times 6 choose 4 ways. So, we're done getting the number of possibilities in situation number 1. We can now proceed finding the number of possibilities in situation 2. Situation 2. Let's do the arrangement of the 7 books selected, considering that the 3 math books remain together. Let me illustrate the 7 books. Let M as the math book and E as the English book. Let's say ganito yung pagkakalatag niya. Let us do the first arrangement of 3 mathematics books. Group the 3 mathematics books as 1 unit. Then, i-place natin separately the 4 English books on each slot. Then, go back to the 3 mathematics books, group as 1 unit. Let us permute this or i-arrange muli natin among themselves. So, we have 3 factorial ways for this arrangement. Next is, let us arrange them all. This time, we'll consider in permuting the other selected books together the 3 math books group as 1 unit. So we have 5 times 4 times 3 times 2 and times 1. So we have 5 factorial ways. So there it is. The number of ways of arranging 3 math books remain together and 4 English books in factorial form is 5 factorial times 3 factorial. Okay, so we're both done in getting the number of possibilities for situation 1 and 2. We can now combine the two possibilities by multiplication principle. For situation 1, we have 5 choose 3 times 6 choose 4. For situation 2, 5 factorial times 3 factorial. Multiply these two, so we have 108,000 ways of selecting the 7 books such that 3 math books are remain together. Or, we can rewrite our expressions or notation in this form. Select 5 choose 3, then arrange. So we have 3 factorial. Next, select again 6 choose 4, then arrange all. So times 5 factorial. So we have the same answer of 108,000 ways. So now, let us try it by yourself once again. Let's check if you can answer the next problem similar to this problem situation. If 3 mathematics books have been selected from 5 different mathematics books, and 4 English books have been selected from 6 different English books, in how many ways can 7 books be arranged on a shelf so that all books of the same subjects remain together? So here, kinonsider na natin yung groupings ng dalawang set of books. To solve for this kind of problem, you can use these following steps. Select and group. For select and group, group together all the books of the same kind selected from each total number of books. Next step is arrange. Arrange each selected group of objects among themselves within their unit. Then, arrange all. Arrange all the books selected and the books of the same kind treated as one unit. Now, if you will apply these steps, which of the following choices would give us the correct expressions or notations of the number of ways of 7 books such that all the books of the same subjects remain together? Is it A, B, C, or D? I'll give you a few seconds to solve for this problem. Okay, and the answer is letter C. Quantity 5 choose 3 times 3 factorial times quantity 6 choose 4 times 4 factorial times 2 factorial. And this is equivalent to 43,200 ways. And you are correct. Good job. Now, to end, let me wrap up everything in these lessons that might be useful to you. Always keep an eye on the keywords used in the problem. The keywords can help you get the answer easily. Keywords like arrangement, ordered, in a row indicates that the problem involves permutation. The keywords like selection, choose, pick, and combination indicates that the problem involves combination. If there are no keywords, or if a problem requires both permutation and combination, visualize the situation and condition presented in the problem, and then think in terms of combination and arrangement. Does order matter or does not matter? Thanks for watching and listening. Good day once again and ingat po tayong lahat.